Hey guys, today I will be talking about Zeno's four paradoxes. Now, his paradoxes can be represented using four pictures: a line, a tortoise, an arrow, and a stadium. But before we talk about Zeno and the paradoxes he created, we need to first talk about a man named Pythagoras. Now, as you all probably know, Pythagoras was the man who invented the Pythagorean theorem. Before he invented this theorem, he held this philosophy that all phenomena in nature are expressible using only natural numbers. Unfortunately, this theory just brings his philosophy crumbling down. Now, as we all know, the ratio of the hypotenuse length to the side length for some triangle can be expressed using two natural numbers, right? If I have a square or a triangle, with side lengths of 5 and 12, then the hypotenuse is going to be of length 13. Then the length of the hypotenuse to the length of the side can be expressed using two natural numbers, depending on the side I choose, right? If I choose this side, the ratio will be 13 to 5, and if I choose this side, the ratio will be 13 to 12. But now what if we have a triangle that has side lengths 1 and 1? Well, you can all do the mental math. You're going to get the square root of 2 for the hypotenuse, but I show it to the right anyway. I write a squared plus b squared equals c squared. Plug in 1s, get 2 equals c squared, and c equals the square root of 2. This is not good, because the square root of 2 is, as you guys probably know this too, the square root of 2, we call it irrational. That is, it is not expressible as a ratio of two integers. And so if the square root of 2 is not expressible as a ratio of two integers, then obviously the ratio of the hypotenuse to the side length, the square root of 2 to 1, that's not going to be expressible as a ratio of two integers either. And if it's not expressible as a ratio of two integers, it's not expressible as a ratio of two natural numbers. And so Pythagoras' philosophy that all phenomena in nature can be expressed using natural numbers falls apart. We cannot use natural numbers in the ratio of the length of the hypotenuse to the side of a triangle in all cases. What this does is because of the repeating decimal, not because of the repeating decimal after the square root of 2, because the decimal doesn't repeat after the square root of 2, because it goes on forever. Many questions are raised about the infinite and about divisibility. I don't have time to go into detail like I did on my last presentation actually, but what I can talk about is the four paradoxes that arose after this discovery, right? This goes back. It's Zeno's four paradoxes. And now what's interesting to me is that the first two paradoxes oppose the idea of infinite divisibility, whereas the last two paradoxes seem to suggest the necessity of infinite divisibility. And so now we have a paradox within a paradox, which I find highly interesting. And so the names of the paradoxes, right? Dichotomy, that can be represented by the line I showed you guys, 1 point on one end and 1 point on the other. We have Achilles and the tortoise, which was represented by the tortoise, the arrow, and the stadium. To start with the dichotomy, we have a drawn line and the two endpoints are labeled A and B. Now to reach point B from point A along the line, we have to reach the midpoint between A and B before we can reach point B, right? But before we reach that midpoint, we have to reach the midpoint of the half segment, of the segment between A and the midpoint of A and B. But then before we can reach that midpoint, we have to reach the midpoint of the quarter segment. So assuming that we can divide the line up infinitely, we can just keep creating more and more midpoints. Now this means that no matter what midpoint is chosen, a midpoint is going to lie before that midpoint. And so to reach any midpoint, we have to reach the midpoint before it first. But since there are an infinite amount of these midpoints, it's impossible to reach any midpoint, and so motion is deemed impossible. But obviously, motion is possible, so it must be that our assumption of infinite divisibility, of being able to divide up the line infinitely, is wrong, is false. That infinite divisibility as a concept is just not feasible. Now, our second paradox is similar in nature, but it is a little different, and it's called Achilles and the tortoise. Now, assume Achilles and the tortoise are running in the same direction, both to the right, but that Achilles is actually running faster than the tortoise. So, for Achilles to catch the tortoise in the first instant, right, in the first drawing, well, Achilles has to reach the point where the tortoise lies in that first instant. But by the time Achilles gets to that point, the tortoise is going to be ahead of where it was in the first instant because, as we said, the tortoise is always moving. So there's no way it can be in that instant. It has to be at least a little bit ahead of that instant. And then in the second moment, for Achilles to reach the tortoise, Achilles needs to reach the point where the tortoise lies in the second moment. But by the time Achilles gets there, the tortoise will be a little bit ahead of that moment because it is always moving, and thus Achilles will actually never catch the tortoise. That is, if we assume that the distance between Achilles and the tortoise is infinitely divisible, Achilles just cannot catch the tortoise. But obviously, if Achilles is running faster than the tortoise, Achilles is going to catch the tortoise at some point. And so what this must mean is that our assumption of infinite divisibility being feasible, of the distance between Achilles and the tortoise being able to be divided up infinitely, is wrong. And so infinite divisibility must not be feasible as a concept. Now, for our last two paradoxes, what's interesting is that one will suggest that both will suggest that the opposite, that infinite divisibility, it must be feasible as a concept. So now for this third one, we have the arrow. Okay, so say we have an arrow at rest, and which lies in an indivisible moment. So, but if the arrow starts to move, well, that moment is actually going to be divided up, right? Because now we're going to have one moment when the arrow is in one place and one moment when the arrow is in another place. What the thing is here is that time is made up of moments. So if we can't divide, so if the arrow can't move across a moment because it's indivisible, since time is made up of moments, the arrow can't move across time, and therefore the arrow cannot actually move at all. Motion is deemed impossible. But obviously motion is possible, and so the concept of an indivisible moment is infeasible, and the concept of infinite divisibility must be feasible. For our final paradox, we have the stadium, which suggests the same thing. And so to see that we have 3 rows of circles, we have one row which we label A, another row which we label B, and a third row which we label C. Now notice that row B is shifted 1 over from A, and that's C 1 over to the left from A, and then C is shifted 1 over to the right from A. Now, we're also going to assume that they are moving in opposite directions as indicated by the arrows. And we're also going to assume that they're moving with the same velocity. Now, if this is the case, right, since B and C are both shifted 1 over from A, it should be the case that they both line up with A in the same amount of time, right? That is the case. But notice also during this time frame that we can say B shifts over 1 circle, right? Because in relation to A, it shifts 1 circle over to line up with A. But in relation to C, it actually moves over 2 circles, right? Because for B to line up with C, which is going to be the case when they both line up with A, B has to move over 2 circles in relation to A. And so now we have B shifting over 1 circle and B shifting over 2 circles in the same amount of time, which is obviously impossible. And so what this must mean is, well, notice that we divided up the distance these rows moved infinitely, right? As far as units of distance, we say the rows moved over one circle to the left, 2 circles to the left, etc. But since doing this creates a paradox, it must mean that this idea of being able to divide distance up finitely is infeasible, and so infinite divisibility must be feasible as a concept. So in conclusion, some see motion as an actual impossibility. I don't, but some do. Others hold the view that Zeno was just pointing out our own contradictions in our notions of space, time, and continuity. And thank you guys, that is my presentation. Hope you enjoyed it.